Hello, my name is HPena, and this is my week 2 video. In my classroom, I see students who are able to follow procedures but do not always understand the reasoning behind them. The scenario I chose focuses on solving linear equations in 7th and 8th grade math, since I teach both and algebra. Um, this demonstrates an imbalance between procedural fluency and conceptual understanding, which is a focus for this week. In this case, students were able to solve an equation like 3x plus 5 equals 17 by following steps, right? So they subtracted the 5 and divided by 3, and they reached a correct answer. However, when I asked them, and this is at the beginning of the school year, when I asked them to explain why those steps worked, many students could not clearly explain the reasoning. One student even said, "You just move the number and change the sign," which again show their reliance on memorized procedures rather than understanding. And so it gets difficult for them when we are now in linear relationships because they don't see that they're both follow the same procedures because they think, oh, there's a y now, so it has to be something completely different. And so it was through courses like this where I am able to compare conceptual understanding with procedural fluency and how they're both connected, right? And so once again, according to the NRC on page 118, it mentioned that conceptual understanding is an integrated grasp, which is important. This also highlighted, like I mentioned, the imbalance between procedural fluency and conceptual understanding. This idea connects to the Carnegie Learning article, which emphasizes that students need to move beyond memorizing steps and develop a deeper understanding of mathematical ideas. While students are successful with standard equations, they struggle when the structure change, like I mentioned, such as equations that require distributing first, for example. This tells me that students are not making strong conceptual connections. Excuse me. NRC and on page 122 states concepts and procedures are interwoven. So they must know the procedures, but then add the why the procedures works, so they can then apply it to future units. And so that's building the concepts, the conceptual understanding of it all. One idea that stood out for me from adding it up is that conceptual understanding refers to an integrated and functional grasp of mathematical ideas. It connects directly to what I am seeing because my students can perform steps, but could not yet have that deeper grasp of what the equation represents at the beginning. Another key idea from the reading is that procedural fluency and conceptual understanding are often viewed as separate, but they are actually interwoven, like I mentioned. This helped me realize that we should not treat procedures and understanding as separate goals in my classroom, but also in my colleagues' classroom, which we did have a little powwow, and it's something that I mentioned, like, are you asking the whys, not just steps? Because during review, all they were doing were reviewing steps. But I was like, it's important for them to know the whys. So ask them why it works. Have them do think, pair, share, discussing the why, not just the how. Because again, scores were kind of low for the 7th grade team, and so we needed to build the rigor for them. Um, So, Riddle Johnson and colleagues also explained that there is a long-standing debate about the relationship between conceptual and procedure knowledge. It stood out to me because it shows that both are important when designing instruction, right? Make it important. It's on page 590 of the Riddle Johnson article. It explains that relationship is bidirectional. So to support my students, I would incorporate visual models such as the balance scale, which is again is it's in the curriculum because one of the ideas of solving equations is through modeling. So representing equation through balance scales and algebraic tiles is one helpful way to visualize that. This helps students see that solving equation is about maintaining equality rather than just moving numbers, right? And so again, I also teach algebra, and so one of the gaps that one of my students had from that in the seventh grade course was that he didn't understand the equal sign, and so he asked me. I'm not sure if I had mentioned that already in the previous course that we had, but it's something that sticks to me because how does a student go without understanding that an equal sign means that we need to maintain balance, that both values are of equal standing, right? And so that was a big eye opener for me. I would also use questioning strategies, asking students to explain why each step worked, not just what they did, like I previously mentioned. I would include structured discussions where students compare different methods and explain their reasoning. This helps build on both conceptual understanding and procedural fluency at the same time. These ideas support both using balance models, questioning, and discussions to build meanings. Overall, this scenario shows that students need both type of knowledge, and as a teacher or and my colleagues, we need to design instruction that connects procedures with meaning rather than treating them separately. This is procedural fluency versus conceptual understanding is one of my favorite to compare because it really is the foundation, and it's a huge difference maker between having a smooth year and having to drill and kill at the end, which is horrible for our students because they get burned out, and so do you, right, as an educator. And so building that connection, that interwovenness, if you will, of procedural fluency with conceptual understanding will make it so much easier for yourself in the remaining year of teaching. So uh, again, it's one of my favorite. And then of course, here are the references that we use for this week. I appreciate you interacting with this video. I will see you next week.